Welcome back, pre-calc students. Today we have an exciting lesson on what we're calling the ambiguous case. First things first, I want to say it's really sunny out right now, and the blinds are kind of shaking. So if you ever kind of see like I don't know, the blinds are moving, so there might be some sun showing up here. Okay, so I'm sorry about that. But yeah, the ambiguous case. Basically, the ambiguous case, and you might remember this from geometry. If I told you that this was 20 degrees and this was a side of 13 and 7, well, this is an angle side situation, right? Or just to be nicer, and I don't want to write it, I'm going to say SSA. All right? So again, we can't use this in proof, and we can't really use this, well, I shouldn't say we can't use it. We can use it, but the problem is that there are multiple triangles that can have a 20-degree angle with then sides of 13 and 7, right? Like this is one option, but I could also draw another. Oh, yeah, actually, you know what? Let me do this instead. I realized that I didn't do this right. Sorry, guys. So actually, I would do something like that. So forget about that. All right, so here's 20 degrees. 13, but now look at what happened with the 7. Instead of it angling out, it angled in. All right? So the idea here is that because there are multiple triangles that you can draw that have, again, the 20-degree angle with the 13 and the 7, we wouldn't really want to use the law of sines here. Okay? If we use the law of sines here, because we have this angle pairing, we would be able to look for this angle. But what do we notice about this angle that's across from 13 and this angle that's across from 13? Well, one's acute and one's obtuse. All right, so to kind of bypass all of this trouble, instead of using the law of sines, and this is the only situation when you have an angle side pairing that I would want you to not use the law of sines, we're going to use law of cosines. And that should save us some trouble. All right? Now, with side-side angle, now we know that there's multiple triangles, right? So when you have side-side angle, you could have two triangles. You might only have one. And honestly, sometimes you might have 0 triangles, depending on if I give you measurements that would give you a triangle, something like that, right? Okay, so this is possible as well. And so let's figure out how we are going to determine that. So we start with number 1. We sketch. We say maybe we have A and B and C. Again, don't memorize the order of the lettering. Memorize where things appear. So now if 7 would be across from A, across from C would be a 6, and then my 29-degree angle is right here. All right? So again, in this situation, I see that I have an angle side pairing, but this is a side-side angle situation. So we are not going to use the law of sines. We are going to use the law of cosines. And how is that going to look? Well, I know that I'm looking for side B, and I know that I'm working on this 29-degree angle. So think of the law of cosines again. What was it? It was c squared is equal to a squared plus b squared minus 2ab cosine c. Well, we have angle C, we have side C, so we can plug in. Those would be the ones opposite of each other in the equation or formula. So 6 squared equals, I could go 7 squared. I would leave my b, and then I would have 2 times 7, still times b, and now cosine of 29. All right, so I know this is kind of goofy, but because we know this pairing, we can plug both of those values into the kind of the outsides of my formula. Now what do we notice? I only have one variable, b's, right? I have b's. Here it's squared, here it's just to the first power, so this is going to actually be a quadratic. So we're going to have to solve a quadratic, which means we need to get one side to equal 0. All right, I'm going to rearrange this descending order, so I'm going to start with b squared, and then I know I have minus this, so it's going to be minus 14. And what I'm going to do is I want to make all of this, the 2 times 7 times the cosine 29, that's the coefficient of b. So 14 cosine 29, and that's all times b. And then lastly, I had a 7 squared, and then I took 6 squared away. So 49 minus 36, I think, is 13. And now we have our quadratic formula, or sorry, our quadratic equation, in which we're going to use the quadratic formula, and oh my gosh, don't we have that program on our calculator? So we would take out our calculator, we'd use quadratic formula, and we need to write in the coefficients. Alright, so A, the coefficient is 1. B is this entire piece right here. It's negative 14 cosine 29. And lastly, C is positive 13. Perfect. So we get 11.07 and 1.17. So this is an example of a situation where if this b value can be either 11.07 or 1.17, well then I actually have 2 triangles. Alright? On this top triangle, because it's longer, I'm going to go with and say that this is 11.07. But now what I need to do is I need to draw a second triangle. I now know that b can also be 1.17. So if I maybe try to replicate, so here's my 7, here's my 29, but now maybe my 6 is something like that. Now I know that this side opposite of b has to be 1.17. Okay? And then I still need the 29 degrees. Alright, so now we have the 2 different triangles that we can, oh, I'm sorry guys, you just realized that you couldn't see anything I was just doing. So here we go. Here is my second triangle. It still has angle of 29, side of 7, side of 6, but now we notice that there's a triangle that has a longer side B, 11.07, and a shorter 1.17. Okay, well, this turns into the same thing that we've been doing now, okay? Measure of angle A, measure of angle B, measure of angle C, A, B, C. The problem is I'm going to have to do this twice, right? I'm going to have to do this again for my other triangle. Alright, now A, B, and C. And let's talk this top one first. Alright, I know that angle C is 29 degrees. I know that A is 7. I know B is 11.07. And I know C is 6. Alright. So what I would need to do is go back to what we learned yesterday. We're going to get the smaller angle first. Alright, now we already have the 29 degrees, which is across from the smallest side. So this is going to end up being the smallest angle. But then I would want to get the next smallest. So I'm going to use law of sines now to get angle A, because it's across from the next smallest side. So I know this is kind of, I'm running out of room here, but I'm going to say that the sine of 29 over 6 is going to equal the sine of A over 7. And so really what I'm just going to do this time to save some time, I'm just going to multiply both sides by 7. So I know that sine of A is going to equal 7 sine 29 all over 6. So let's do that on the calculator. 7 sine 29, whoa, not tangent, all over 6. So now I know that the sine of A is 0.5656, but I don't want the sine of A, I want A. So I need to take the inverse sine, and I get 34.44. So angle A is 34.44 degrees. Now we know angle B, we don't have to do any tough work for that. All we do is 180 minus our 2 angles. So 116.56. 116.56. Alright? So again, the step here is you need to start by using the law of cosines to get the 2 options, and then you can go to law of sines to get your angles. All right, now we have to do the same thing here because we have multiple options for triangles, okay? So now, once again, I'm looking for the smallest angle. Well, the smallest angle is going to be across from the 1.17. So I know I'm going to have to use sine 29 over 6 equals sine of b over 1.17. And when we do this, I'm going to say that the sine of b is equal to 1.17 sine 29 all over 6. So let's do it. 1.17 sine 29 all over 6. And here we can use the inverse sine again to get that b has an angle measure of 5.42 degrees. 5.42 degrees. Sorry guys, I should finish this up. A was 7, B was 1.17, and C was 6. Alright, so lastly, now that I have my two angles, I can go ahead and take them away from 180, and I get 145.58. Okay, so again, the idea here, you need to remember, got to remember here, that when you're given a situation when you have side-side angle, there could be multiple triangles, okay? So you cannot not just go right to the law of sines. If you have side-side angle, you go to law of cosines, okay? It's the only time when you have an angle pairing that I want, angle side pairing that I want you to use law of cosines. All right. Now, in the interest of time, I am going to skip number 2 for right now. I would like you to try number 2 on your own. But I would like to move ahead to some word problems just so you can kind of see what is expected of you. All right. So now I already kind of drew in this diagonal. I don't know. I wasn't thinking when I was kind of thinking over my notes what I wanted to say. But we know that parallelograms have what? Opposite sides that are parallel and congruent. Alright, so in this situation, I actually don't necessarily have to use the law of cosines, because if I know that both sides are 10, well then this side is 10, and this is actually a side angle side situation. Alright, and so side angle side means that we are going to use the law of cosines. Why? Because we don't have that angle pairing. Now, I am going to have to do this again. Oh gosh, great parallelogram. I am going to have to do this again because I also need to get the other diagonal, right? Need to get the other diagonal, and hopefully we remember that if this angle in the bottom corner is 40, then this angle over here is going to be supplementary, or 140. So we'd have to do this problem twice, but it's not too bad. It's really not. So, in this picture, I'm going to say that my side across from my angle, C squared is equal to 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 40. What's going to be the only difference when we do the setup here? Well, it's still the side across from the angle I have, so I'm still going to say c squared, and I still have 8 squared and 10 squared, so minus 2, 8, 10. The only difference is the angle measure. The angle is now 140. Alright, so in both of these, the setup is pretty much the exact same. You're using the same sides and whatnot, it's just the angle changes, okay? So we would go to our calculator and we would plug this in. So, 8 squared plus 10 squared minus 2, 8, 10 cosine 40. And we would have to take the square root of that to get 6.44. And in our other option, it would be a little different. We'd have what? 8 squared plus 10 squared minus 2, 8, 10. Where am I? Cosine 140. And we'd square root that to get 16.93. Alright, so in this situation, I would actually want you to understand that if you have these two sides, you can actually turn this into a side angle side to make it a little easier. Now, in something like number 5, we cannot do that. We don't have any rules about airplanes and aircraft carriers and whatnot. So in this situation, we need to recognize that we are given an angle side-side or side-side angle situation. And so again, because it's side-side angle, we're using the law of cosines rather than the law of sines. So we would say that our angle pairing, or angle side pairing, is the 8 and the 37. So we're going to say that 8 squared, because it's across from the angle we have, is equal to 12 squared plus b squared, because those are the two other sides, minus 2 times 12 times b, and then cosine that angle. So once again, we're going to end up with a quadratic, and we're going to be able to use that calculator program to help us out. So again, I want to solve for 0, because you have to solve for 0 to use the quadratic formula. And we write it in descending order. So b squared minus, what do we have here? 24 cosine 37, b. And then what do we have? 144 minus 64 is, oh, I did that wrong. 144 minus 64, we have positive 80, all right, plus 80. And so now we have our quadratic. Let's put it into the quadratic formula. So our coefficient of b squared is 1. Our coefficient of b, negative 24 cosine 37. And then our constant is 80. And we get our two options. So b would be 13.03 kilometers or 6.14 kilometers. And me, being a poor teacher, didn't even really read the question to you guys. I'm terribly sorry. In this situation, are we solving for everything, or if we just want to know how far is the plane from the destroyer, well, we just answered it. We just answered that question. Alright, if it's the 13.03, it's probably how this picture looks, right? We'd put 13.03 here. If it was closer to the 6.14, it would probably look something a little closer to that, right? We'd have a 12, we'd have our 8 there, this would still be the 37, but now it would kind of be angled in like this, and that would be the 6.14. Okay? So that is not too bad. Alright, and one more time I am going to ask you guys, and I will check on this tomorrow, or at least we'll go over them tomorrow. I would like you guys to see if you could try number 6 on your own. Alright? It's very, very similar to number 5. So if you're having trouble on number 6, please take a look back at number 5 to see if you can kind of work your way through it. Alright? I hope that this is making sense. Please, please, please remember, whenever you have that ambiguous triangle, that side-side angle, whenever you have this guy, you have to remember we're using the law of cosines to help us out rather than the law of sines. Alright? See you next time.